Hello everyone. In this video, I'll be covering demo problems to find max and min of a list of integers. Let's get started by defining a variable L and initializing it to a list of integers. I'm going to type the integers as 4, 1, 2, -2 and 6. The goal right now is going to be to find the max item in list L. We could get started by initializing max underscore val variable with 0. Then I'm going to write the for loop as for val in L. For now, let me just print val. We need to compare the current item with the previously known max value. If the current item's value is greater than the previously known max value, we want to update the max value to the current item, correct? So I'm going to write my if condition as if val is greater than max underscore val equal to the current value. Let me display max underscore val outside my for loop. Observe that we are getting the correct output for this particular list of numbers. What is wrong with this initialization assumption in line number 4 here? What if my list contained all negative numbers? Let's say that my list contains the integers as -1, -2 and -4. Now the code is producing 0 as the max val, which is not the correct output. So how can you handle this particular issue? The best initialization value is going to be none always whenever you're trying to search for a specific value within your set of values. Observe that we are now getting an error which says type error comparison greater than not supported between int and none type. That's because you cannot compare val variable which holds an integer with max underscore val variable which holds a value of none. Let's step through this program from the beginning. Max underscore val is initialized to none. Iteration 1 of your for loop is going to have val variable as -1. Then in line number 8, you're comparing -1 to a value of none, which does not make any sense to Python. Recall that we covered a design pattern for this as part of the string lecture. You need to explicitly handle the case where max underscore val is none value. You can do that by writing an or part of the if condition in front of the search condition. So you're simply going to say max val equal to none or your search condition. Observe that right now we are not getting the error. That's because during iteration 1 of your for loop, maxval is going to have a value of none. Why is that the case? That's because we initialized max underscore val to none just outside the for loop. When your if condition is of the form true or something, the second part will never get evaluated because of short circuiting. True or something is always going to evaluate to true. So Python is going to execute the line of code within the if condition, and it's going to update max underscore val with the very first iteration value, which is going to be -1 for this particular list over here. So what if we want to go through the rest of the iterations? That's going to assure that the first half of the condition always evaluates to false, because once you set max underscore val to the very first item's value, this part of your if condition will always evaluate to false. False or some other value implies that you will always evaluate the second part of the expression, which is the actual search condition here. What if I were to change the goal around and say that you have to keep track of both the max item and the corresponding index of it? First of all, observe that after we changed the initialization to max underscore val variable as none here, we are getting the correct output as -1 for the second list, which is the correct value. Let's go through the updated version of this goal here, which is supposed to find the max item and its corresponding index. That's a very simple enough change for you to do. You can keep track of another variable called max underscore val underscore index and initialize that to none outside your for loop. The only problem is your for loop is iterating over the values in the list L here. You need index positions, correct? When you have index positions, it's very easy to extract the values by using indexing. But when you have just the values, it's not straightforward to extract the index, especially if your list contains duplicate items. What is going to happen when you run the index method call when you have duplicate items within the list is that index method call will always return the index of the first matching value from the list of values. So whenever you have to deal with indices, it's best if you use the range built-in function or the enumerate built-in function. So I'm going to use the range built-in function. I'll be passing len of L as argument for range built-in function to ensure that we are able to iterate over the indices here. I need to replace the variable val with index or I or idx. How do we get the value now? I'll have to say val equal to L of index, and now we can keep track of max underscore val underscore index by updating the value of the variable max underscore val underscore index with the index variable's value. Let me display max underscore val underscore index here. Observe that we are getting max value as -1, which is at index position 0. We are getting the correct output here. What if I switch back to the previous version of the list? We are getting 6 as the max value and 4 as the corresponding index, which is the correct output. If we were to switch the goal of this particular problem to find min item and its index, the change is very simple. You just need to focus on the search condition part here. Right now we are comparing val against max val using val greater than max val. We just need to say val less than min val. Of course, we'll have to replace all of the references of max with min. So I'm going to say min underscore val and min underscore val index in all the places where we have been using max underscore val and max underscore val index. If I display min underscore val and min underscore val underscore index after the for loop, observe that for the first list we are getting min val as -2 and the corresponding index is 3, which is the correct output. For the second list, we'll be getting min val as -4 and the corresponding index is 2, which is the correct output. Please make sure to understand this design pattern for search using a for loop really well. You're going to use this extensively as part of future projects. I'll wrap up this video here. In the next video, we'll be going through an updated version of the restaurant lookup problem.